Hello, Andy Van Straten here from Ziva Dynamics. I thought I'd put together a quick video today about the new features in Ziva Cloth and how they might be relevant to you for solving things like fascia. So in this scene I've got a couple of tissue objects and there's some real basic animation on them. So this end bone here just kind of twists in space and the tissue objects sort of collide against each other, and the idea is that these would represent something like muscles in the forearm or something like that. And so what I'm going to do is solve a cloth object over top of those tissue objects. So first thing I'll do is turn this into a cloth. So under the Ziva menu I can go add simulation component cloth, and then if I play this back now, basically you have the functionality that you've seen up until this point. So at this point I could have added sliding attachments or things like that, but what we really want is a feature where we can shrink down the cloth over the underlying objects. So we have that now. So if you look in the Z material node on the cloth, we have two new attributes, one of which is rest scale, and I'll get to pressure in a bit. So with rest scale you can see that it defaults to 1, which means that it's going to just preserve the size of the cloth at default. But if I was to set this to something like 0.8, the cloth is going to try and shrink down to 80% of its size at default. So all the edges of the cloth are going to try and scale down to be 80% of their original length. So if I solve one frame right now, you're going to see that instantly the cloth tries to snap to that position, and that's not always desirable because if you have a sharp jump like that on the first frame, sometimes collisions will get missed if the jump is severe enough. So what we really want to be able to do is ramp on this effect as part of maybe the run-up or something like that. So because currently the attributes on Ziva materials are not keyable, they're defined at the solver start frame, we need to be able to ramp this effect on over time. So if you have a look in the Z cloth node, you'll see that there's a rest scale envelope attribute, and what we can do is key this attribute and these two will multiply together to give the final effect. So if I set it to 0, currently the effect will be completely negated, and what I can do is set some keys. So on the first frame we'll set it to 0, and say on frame 5 we'll set it to 1, and I'll just add a cache as well so we can scrub through this. Now if I step through a few frames, you can see that over time the effect is coming in. So if I just play this back now, cool. So you basically get the idea here, where that cloth is shrinking down over the underlying objects. Now you'll also notice that if I switch to paint for a second, if I do a cross section of the tissue objects, and I'll change color for the fascia. Say you spent some time modeling your fascia really nicely to represent the valleys in between the muscles, like that, and then you activate the rest scale attribute. This is all made up of edges, right? And if all these shorten, what's going to happen is your fascia is actually going to effectively give you a hull. So while it is kind of doing all the nice shrinking down over the underlying objects as they move, you're going to lose some of the valleys between the muscles. So wouldn't it be great if there was an attribute where you could put an external force back into the fascia and it would push these vertices back down, so you would get the best of both worlds, and these valleys would hopefully return. And we do have that. So And I'll just clear that cache. We go back to the Z material node, and we have this pressure attribute. So if I add on something like, so if I set this attribute to something like 20, and just like with rest scale, I'm going to key the effect on over time. We should hopefully see some of those values return. So I'll play this back now. You can see immediately that the pressure is pushing back in. So I've still got a bit of slack with the cloth, so I could probably go, it's about finding the right balance between these two attributes. So I might want to go back to the Z material, maybe make the rest scale 0.7 and the pressure, double the pressure. Play that back. And you'll notice here that there's no attachments or anything like that. Oh, it's the collisions that are doing all the work, which is pretty cool, I think. And you'll also notice if I scrub back through the timeline now that, and maybe isolate this, you'll see like all this super nice sliding effects happening. And this is a really powerful feature, I think, because you'll also notice that this simulation is coupled, so the cloth is pulling back on the tissue objects and they're pushing back. So that's exactly what you see in nature. You don't have to do it like that. Obviously, you can instead of using, if this is your muscle sim, you could simulate the tissues first to a limbic, and then bring them back in and convert them to Ziva bone objects, and then run your fascia over that. And that's the pipeline that we've been using in-house so far. That's the one I used on the lion as well. So yeah. Another thing you can look at as well with this stuff is there's an attribute on the ZSolver node called collision point spacing, which is this one. And so if you're finding that the objects you're colliding against are quite low resolution, because our collisions are point and volume tests, you can effectively flood your objects with more collision points using this attribute here. So what this is saying is that for every 0.01 Maya units, put a new point on the mesh. And so you can see on the, if you look closely on here, is that we have, I'll do another sim to make it obvious. You can see now that there's a lot more green collision proxy points showing up because I've effectively flooded the meshes with more collision points. So this would be too many. You don't need this many for your simulations, but that's an idea for you if you're finding that your collisions are getting missed. And then of course the other thing that contributes is substeps. So you need, in some cases, a lot of substeps to catch every single collision. So yeah. Yeah, that's the new stuff in cloth. So hopefully that's useful to you, and yeah, thanks for watching.